So next topic is heat budget of Earth. So this is important for prelims point of view, because they can ask you question in the objective or the MCQs that arrange this following on the basis of absorption or the radiation of the heat, right? So but heat means energy which has been received over the Earth. It is received over Earth's surface. Right? Budget means this the account of incoming radiation and outgoing radiation. So you should understand first the meaning and the definition of the concept. Then which of these two which are reaching there on the Earth. So we have to discuss in this topic. They are the amount of energy which has been reaching there on the Earth, and also they are the heat or the account of heat which has been coming in the form of incoming radiation and going out of in the form of outgoing radiation or terrestrial radiation. So which is taking process there on the Earth. So we have to take account of these all, right? So let us start with this heat budget of Earth. So this heat budget of Earth I am discussing according to G.T. Trivartha. So he is a very famous and well-known climatologist. So he says the amount of heat reaching over the surface through atmosphere, we assume as it is reaching in form of 100 units or 100%, right? So means we can say the amount of heat which is reaching there on, amount of energy which is reaching there on the atmosphere, reaching on there on the atmosphere, that is 100%. And then after that is reaching in the form of 100 units. So we have to take all the account of 100% or the 100 units of energy which is there on the, or which is reaching there on the atmosphere than to the Earth's surface. So he has explained, or he has maintained the account of incoming radiation, so that we can say incoming solar radiation, right? So this incoming solar radiation, it comes in the form of short waves. And as we have already discussed in the previous class, that short wave is transparent for atmosphere. Means this will not be absorbed much. But when it comes in the lower atmosphere, this has been obstructed or absorbed or reflected back by the different object present in the atmosphere, right? So this in total there is about the account of 100 units or the 100% of the energy which is coming in the atmosphere. So it has been said that there the amount of heat which is reaching there in the upper atmosphere in the form of solar radiation. So that is about 100 units, right? Upper atmosphere in the 100 units. So this is the account of incoming radiation. Then after 100 unit, when it is reaching there in the atmosphere, so it reaches there or it comes down into the lower atmosphere. So where there is a presence of clouds. These clouds, they reflect back about 27% or 27 units back into the atmosphere. And then also there are some of dust particles present in the atmosphere. So we have discussed this all. The component of the atmosphere: dust particles, water vapor, and also the gases. So water vapor we can take as the part of clouds. We can take the as a water vapor. So there are the dust particles. So dust particles has been receiving the insolation, incoming insolation, and then reflecting back into the atmosphere. We have discussed this. These are responsible for the scattering and diffusion through the process of scattering and diffusion, right? So this has been there by 6 unit or 6%. Then also this sun's radiation is also reaching there in the more of lower atmosphere, and this has been absorbed by there are the few of the gases which is present there in the atmosphere, that is O3. So this absorb about 14% or the 14 unit, 14% or 14 units. So how much accounted is there? 27 plus 6, 33, and 14. 33 and 49, this is 47%. And from the surface, 2% radiation back to the atmosphere immediately through the process of, or 2 units back to the atmosphere immediately through the process of albedo. So concept of albedo we have discussed again in there in the last class. So that in total it is 49%. 49% is ineffective energy which has been reflected back into the atmosphere without of significant heating on the surface. So how much is left? So it is left only 51 units. They are on the or reaching there on the surface, which makes the ground warmer, or earth has been heated only by the 51 units of heat which is reaching there on the surface. Thereafter, so we have to keep this account of the total of the 51 unit. So this 51 unit is also responsible for heating of Earth's surface. So this 51 unit has to be transferred there back into the atmosphere, otherwise the Earth will become excessively warmer. So this is the whole account of incoming radiation. Thereafter, there is another process taking place there on the surface of the Earth. There is a outgoing radiation. So outgoing radiation is always there from the surface of Earth, or simply we call it a from Earth. So this incoming radiation and the outgoing radiation should be balanced, otherwise there will be a destructive or the catastrophic effects of it. So in this process, there this has been radiated back into the atmosphere, about 17 unit into the upper atmosphere, and 6 units have been absorbed by atmosphere. 17 unit has been sent back into the atmosphere by the process of terrestrial radiation. So from the earth it has been radiated minus 23 units. Then also 9 units has been radiated back into atmosphere by the turbulent convection. Then after 19 units has been sent back into the atmosphere by the process of evaporation. So this in total of these account 23 plus 9 plus 19. It is all total 51 units. 51 units. And if you see here on this account, they are the incoming radiation 51 units. 51 units reaching their own surface, and 51 units has been radiated back into the atmosphere. So that therein the total of the 100 units account has been maintained there from the earth surface to the atmosphere. So this process there is a balance of heat maintained between earth and atmosphere. And also one more important thing is, If we see this according to the basic law of thermodynamics, as Earth absorbs energy from Sun, it must eventually emit an equal amount of energy to space. The difference between incoming and outgoing radiation is known as planet's radiative force, that is called RF. And then radiative force is difference between solar irradiance, that is sunlight, absorbed by Earth, and energy radiated back to space. So this is radiative force changes to Earth's radiative equilibrium that cause temperatures rise or fall over decadal period are called climate forcing, right? So just understand these three terminologies here. One is radioactive force. Radioactive force is according to the law of thermodynamics, it is the Earth's absorbed energy from the sun and must eventually emit equal to the amount of energy to the space. Means what it has been received should radiate back into the atmosphere. So there is difference between the incoming and outgoing radiation is known as radioactive force or the planet's radioactive force. So means this balance between incoming radiation and the outgoing radiation has been called radiative force. Then after, the radiative force is the difference between the solar irradiance absorbed by the earth and energy radiated back to the space. So this is the difference, means it is coming to the 51 unit and also radiated back into the 51 unit. So that is the energy which has been radiated back to the space. Right. Number 3, this is changes in the Earth's radiative equilibrium that cause temperature to rise or fall. Are this over the decade is a climate forcing. Means suppose for example the significance of, or we can also say in the other words, this is significance of heat budget, or is a natural process. So what is it? So suppose for example their incoming radiation is greater. I am marking it with 3 arrows, right? And outgoing radiation is smaller. I am marking with a 2 arrows. This is incoming radiation and this is outgoing radiation. So means there will be disbalance or imbalance in the incoming radiation and then the outgoing radiation. This will lead to more heating of Earth. So this more heating of Earth will lead to the global warming. Global warming means we can say this is a balance has been disturbed in the negative flow. So negative flow of energy is responsible for global warming. So it is responsible for the global warming. Then after, at the same time, incoming radiation is lesser than outgoing radiation. So this will be cooling or global cooling that will lead to glaciation, right? So that is the concept which is discussed here. This is climate forcing. So this will lead to the climate forcing means climate change. It means changes in the Earth's radiative equilibrium. When the changes will take place, radiative equilibrium means when there is a disturbance in the balance of the incoming and the outgoing radiation that cause the temperature to rise or fall over the decades will be over the decadal periods is called the climate forcing means climate change. So this balance has to be maintained there between their balance has to be maintained there between the incoming radiation and outgoing radiation, right? So this way the Earth maintains its balance, right? So that is a heat budget.